Hello and welcome to another video. We're going to be talking about here capital investments. Again, the credit goes to a very good website. It's called excel-easy.com. I take this website seriously because it has a lot of nice things that we could really use, and they encourage you to do so, of course, as long as you give them the credit. So let's take a look at this capital investments and also how to use Solver in order to come up with the most, what we call the best possible decision, and not the perfect decision, of course, because we are looking here for optimal decision optimization. So this is again a capital investments. The investment, we have 7 of those. We have 1 through 7. This is the profit from investing in uh, this type of portfolio. Let's put it this way: it's multiple of those investment 1, and of course the capital for investment 1 is 2. Those are the constraint. If you take a look at all this, the constraint for our capital, we don't have more than 50. So the very first constraint is 50 of the total of all these that the model is going to be able to pick up for us as part of the optimal solution. Then it's the other restriction. It says you could only choose 1 or 2 from the investment. So we put the 1 and the 2, meaning this is a binary value. The binary of 1, that's mean it does exist. The 0 is going to be not there. I put 1 and I put 2 here. So in order for us to choose one or the other, the constraint has to be less than 1. I would like you to give me your attention to understand the logical thinking behind this relationship. So if we chose this one here to be part, or if the solver chose this investment 1 as part of the solution, this could not be chosen because it does not satisfy the constraints of less than or equal to 1. So if both of them were selected, that's going to give us 2. So therefore, that's not going to be satisfying the constraints here. So it does not have it. That's mean we're one or the other. It could be none, based on the fact that we might not choose any one of them. If none of them, that means it's going to be 0, which is still a healthy relationship between 0 and less than or equal to 1, which is true. So this is very important for us to understand. The same thing, it's still a binary, 3 or 4, meaning we can choose only 3 or 4 as part of the portfolio. Both of them are going to have 1, but the constraint clearly stating that whatever you choose from this row between those two must be less than or equal to 1. You could choose 1 at most. You could choose none. So as long as the relationship is going to be less than or equal to 1, we're going to be in good shape. This is a little bit tricky, but you're going to be able to understand it very easily if you give me your attention, and also if you can see again the logic thinking behind the relationship here. What they're telling us verbally, that only 6, 7, if 5 does exist. So the reason that we put -2 here, just in case this happens to choose 6 and 7, it's going to guarantee the relationship less than 0. So if that was chosen, and this is it chose, let's say if 6 is chosen by itself, then we must choose 5. Why is that? Because in order for this to be less than 0, so choosing 6, it's going to be 1 and -2, which is going to be, in this case, -1, which is basically is still a valid relation, meaning -1 is less than 0, which is a true or valid constraints. If I chose both of them, which is allowed as long as I choose 5, so -1 plus 1 plus 1 is going to give me 0. That means it's still going to be 0 minus 0. So if you choose 5, I'm sorry, if you choose 6, maybe you didn't choose 7, it's going to be -1, which is -1 still minus less than or equal to 0. If you choose both of them, it's going to be actually 0 in this case, and meaning we're going to have two of them as part of the solution. Let's go ahead and do the calculation, which is we're going to be using the sum products. Everything is organized nicely. Everything is less than or equal to. So this is going to help us when we form the solution inside solver. But for now, we have to use the sum products for each of these calculations. And remember that sum product is really very, very helpful. Uh, 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 excuse me. Sum product is a very helpful function to allow us to multiply while we're adding multiple ranges. So in this case, we do understand that this one here is going to be multiplied comma in order to multiply for whatever the solution is going to be provided for us. Let's go ahead and lock this with using the F4 in order to save us some time. This way, if I do this, I will be able to go ahead and drag the rest, knowing this is an isolated range by itself, so that's the one that I need to lock it. Here we go. So this is locked while I move the relative address to C8 through I8. The same thing for people who haven't really taken Excel or haven't really practiced enough with it. That's why we actually doing what we're doing here to lock this range, the yellow range. That means it's going to be used with every other calculation, and we're ready with that one. So obviously, we're going to go ahead and do the total profit, which immediately is going to remind me that the fact when I choose the solver, I must actually seek the maximization, because when it comes to profit, that's our ultimate aim or goal, is to maximize it. If something has to do with cost, has to do with reduction of some sort of distance or reduction of the amount of ingredients in order to more efficiently produce something, then it's going to be minimized. However, for this one here, it's going to be very, very clear as a maximization problem. So which is basically, this is going to be this here. I forgot to use the sum products. So let's go ahead and put sum product, and that's immediately going to give me the, here we go, sum products. And we're going to go ahead and select that. We could go ahead and put this one here. If we press F4, it's fine. If not, fine, because it's only going to be one single value with it. So I'll go ahead and do it anyway, so just to be consistent. And here we go. Of course, it's going to give me 0 at this moment. It will be interesting to see what would be the choice among all these different options that are available for us to capitalize, maximize is a better word here, on our capital investments. So let's go ahead and do that very quickly by going to home, data. I'm always fascinated by home because that's where most of my work is. And I'm going to go ahead and select this one here as my objective, my set objective. It is maximum, so it's already there. And I need to be careful here in order to make sure that you understand at this moment that we have these to be the one that we're going to really asking solver to be able to come up with the best choices. And this is binary, so it's going to be 1 or 0, and I'll show you how to actually apply that very nicely. And now, if we go, let me go ahead and delete those. I was playing with it earlier, so you wouldn't have to worry about that. So you could really know how to do it yourself. Adding, I'm going to add all this because all of them have the same exact relation, which is less than or equal to, and this is immediately the first one, and it's going to be less than all these constraints. So that's really, really good. We could add that. There's another constraint I would like to have, which is, in this case, these here, I would like them to be binary. See that? Those are binary, okay? And so this value should be either 1 or 0 binary. So we could say, okay, that's actually done with our constraint. And notice I'm going to go ahead and choose that as a simplex solution, make and constraint variable non-negative. I'm going to go ahead and take that we might be ended up getting actually -1 for this one here, just in case here. So I'm going to go ahead and, of course, go ahead and solve it, and let's see what we're going to get. Absolutely great, because now I'm going to accept this. So I'm going to go ahead and say, okay, leave me with the answer. And now it's a total profit of 146. Obviously, -1, it's clearly here was one of them chosen, not both of them. So obviously, if you look at the solution, 7 was chosen, 6 was not included, because this is resulted into -1. This did meet the constraint, 47. This is meet the constraint, meet the constraints, meet the constraint. Now we're going to take a look closely at the choices made by the solution. We're going to be having investment in investment 2, investment 4, investment 5, and investment 7 in order to get 146, which is that maximum possible profits that we can get from this investment. One last reminder to make sure that you might put here yes or no, or on or off if you want, true or false. It doesn't matter, because those are binary values. Whatever language you're comfortable with, that will be great. I hope you learned something, and I hope you will be able to practice that not only with this symbol data. Try to be a little bit brave, I'm talking here intellectually brave, and trying to go ahead and experience with other problems. Thank you, and I'll see you in the next video.